Today we have a problem based on system of particles, and in the situation today we are given a cart which has a orifice at its bottom and is spilling from sand. Now for the cart we are provided with the initial mass of the cart, the velocity v, and the constant force it is being pulled by is capital F. Now we need to find two things in this problem. The first one is the acceleration as a function of time and the velocity as a function of time. These are the two findings we'll have to make. Now let us call the spilling rate of the sand from this cart as R. So R has to be some sort of mass divided by the time period. So R is basically the rate at which sand is being spilled on the tracks from the cart. So R is m over t in terms of unit. So it's like kgs per second. Now, talking about the acceleration as a function of time, we have the force divided by mass. Now the trick here is the mass is not constant, it is a variable and time dependent. So F is the constant force it is being pulled by, so that will remain F, but the mass as a function of time will be the original mass m0 minus the rate times the time which has elapsed ever since the cart has been moving for a time period of t. So we have m of t as m0 minus r t, and F is the constant force F. Right, so we have the acceleration as the function of time. We have our very first answer, and this was it for the acceleration as a function of time. Now since we are to evaluate the velocity as a function of time, we know that for velocity as a function of time, we know that a is equals to dv over dt. It's just the rate of change of velocity, right? So we'll be sending this over here, basically cross multiplying, and we'll get the velocity as integral of a with respect to time. Putting the limits, we have velocity from initially it was 0 at time t is equals to 0, and velocity v at any arbitrary time t. Now we have the value for acceleration over here, which is f over m0 minus rt, and integrating this with respect to time. So f will be treated as a constant, right, of course, and the velocity over here is v minus 0. Now we have the velocity as a function of time upon integration is f by r ln m0 over m0 minus rt, which is going to be our final answer for the problem. Since we were to find the velocity as a function of time and the acceleration as a function of time, now we have both the values to us, right? That brings us to the end of this question, and yeah, thank you for your time.